All right, take a look at your opener here. It says find the value of angle B if AC is the diameter and your radius is 2.5. Well, if AC is your diameter and your radius is 2.5, that means your diameter AC is actually 5. Right? To look at that value of angle B then, right? If I use my triangle that's here, we can check to see if angle B is a right angle by checking to see if 5 squared is equal to 3 squared plus 4 squared. 5 squared is 25, 3 squared is 9, 4 squared is 16. Since we get 25 equals 25, that tells me that angle B here is a right angle. Right? Now, what we are going to look at then is we are going to be comparing this type of angle where your vertex is on your circle compared to the arc that that angle will make. So here's the angle that we're looking at here for angle B. It creates my arc AC. Right? Since AC is a diameter, this arc here is half of your circle. So it is 180 degrees. We are comparing that to the angle that makes it, which was 90 degrees. The relationship that's here will always be true. When you have an angle whose vertex is on your circle, it will be half as big as the arc that it makes. So for example, if my angle that is on my circle was 50, this arc that it makes would be 100 degrees. So we've now learned two types of angles. Your central angle, your vertex at the center of your circle, it is equal to the arc that it makes. Vertex on your circle, it's half as big as the arc that it makes. Right? Two separate types of angles. That angle we have there, where your vertex is on the center of your, when your vertex is on your circle, it is known as an inscribed angle. It is an angle whose vertex is on your circle and then whose sides contain two chords of your circle. So we are looking at this angle right here. Now, technically, that inscribed angle makes three arcs that I have labeled there. Only one of those arcs is the arc that it relates to, though. Only one of those arcs is known as the intercepted arc. And that is the arc that lies inside your angle. So we're looking at arc 3 here. That is what is known as your intercepted arc. The arc that lies on the interior of your angle. Will be known as your intercepted arc. Now, two other things to worry about is I can worry about taking, instead of just doing that intercepted arc and the inscribed angle, I can have multiple angles on my circle in the case of a polygon. An inscribed polygon is a polygon that has all of the vertices. So here we have your quadrilateral on your circle. That quadrilateral is known as the inscribed polygon. That circle that goes around there, it is known as your circumscribed circle. So your inscribed polygon is that polygon inside. That circle going around is known as a circumscribed circle. So really there's two ideas we're going to go over today. The first one just deals with that angle that's there. That inscribed angle, such as my 50-degree angle here, and how it relates to my arc. It is always half as big as the arc that it makes. And that is theorem 10.7 here. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So those two types of angles then. Difference between a central angle. Vertex is at the center, and it's equal to the arc that it makes. Your inscribed angle, your vertex is now on your circle, and it's half as big as the arc that it makes. So looking at example 1 then, first thing it wants us to do is find the measurement of angle S. Angle S is on your circle, so it is half as big as the arc that it makes. The arc it makes here is 60 degrees, so my angle would be 30 degrees. Now for B, you do need to be careful. In B, they want us to find arc RQ. Now arc RQ does not have an inscribed angle that makes it. The angle they give us here is my angle QRS. Since QRS is 37 degrees, arc SQ, or QS, will be 74 degrees. Now what they want us to realize then, if I go halfway around my circle here, this whole arc here is 180. Since arc QS is 74, arc RQ is 106. Second one here, it says find the measure of arc HJ and the measure of angle HGJ. So they give me angle F here to be 39 degrees. That means arc HJ is 78 degrees. They also want us to then find angle HGJ. HGJ just so happens to make arc HJ also. So it'll be half of the arc. So this angle will be 39 degrees also. What do we notice about our two angles here? They're congruent to each other. They're both 39 degrees. And that will actually always be true. When two angles intercept the same arc, notice how angle G and angle F both make your arc HJ. If they intercept the same arc, they will always be congruent to each other. That's actually your next theorem that's there. If two inscribed angles of a circle intercept the same arc, those angles will be congruent. So in example 3 here, it says name two pairs of congruent angles. Well, if I look at angle P makes arc SR. Likewise, angle Q makes arc SR. So angle P is congruent to angle Q. However, if I go the other way, looking at angle S makes arc PQ. Angle R makes arc PQ. So angle S will be congruent to angle R. There's your two sets. Taking a look at our next one there. Find the indicated measure. The first one, they want angle GHJ. Vertex is on the circle. It is half as big as the arc that it makes. For number 2, they want arc CD. Once again, vertex is on my circle, so it's half as big as the arc that it makes. Sometimes they'll give you the arc. Sometimes they'll give you the angle. The relationship is still there. And then the last one here, angle Q makes arc RS. Angle T makes arc RS. So since angle Q is 31 degrees, angle RTS is also 31 degrees. Right, 2 more ideas to go over. The first one, we actually did in the opener. Talks about if I have a right triangle in my circle. To have a right triangle in the circle, that would mean that the arc that it makes would have to be 180 degrees. The only way for that to happen is if this hypotenuse is actually the diameter of your circle. So the measurement of angle ABC here will be 90 degrees. If and only if AC is the diameter. The right triangle is inscribed in a circle. The hypotenuse is the diameter of that circle. Brings us to our last idea we're going to go over today. Talks about if I put a quadrilateral inside my circle. When that happens, the angles that are opposite each other, for example, angle E and angle G, they're going to have to be supplementary. Meaning if angle E is 100 degrees, angle G is not equal to it. Angle G is a supplement of it. So in this picture, angle D plus angle F. So if angle D is 60 degrees, angle F is 120 degrees. And then angle E plus angle G will also have to equal 180. The only way to inscribe a quadrilateral in a circle is if those opposite angles are supplementary. So if that's the case here, angle P and angle R are opposite angles. So 100 plus Y must equal 180. So Y would have to be 80. Likewise, X and 88 will have to be supplementary. So X will have to equal 92. When I come over to example B, M and K are opposite angles. So 3Y plus 3Y must equal 180. That tells me 6Y is equal to 180. So Y is 30. Likewise, angle J and angle L are opposite angles. So 8X plus 4X will have to equal 180. So I have 12X equals 180. So we divide, we get X to equal 15. In your next one, it says a right triangle is inscribed in a circle. All right, maybe my right triangle will look like this. There's my right angle. It says the radius of the circle is 5.6 centimeters. It says what is the length of the hypotenuse? If the radius is 5.6, the diameter is twice as big. So it's going to be 11.2 centimeters. And then as we learned today, your diameter is equal to your hypotenuse. So your hypotenuse is also 11.2 centimeters. Brings us to our last example. Find the values of A and B. Opposite angles are supplementary. So 5A plus 90 will equal 180. Subtract your 90, we have 5A equals 90. Divide by 5, we get 80 equal 18. Likewise then, B and D are opposite angles. So 96 plus 4B will also have to equal 180. Subtract our 96. 4b equals 84. Divide by 4 and we get b to equal 21. Right. Here's your homework then. Page 676, numbers 3 to 16. And please let me know if you have any questions. Other than that, have a good day, everyone.